Hey class. So before I start, I just want to make sure that you guys are, hoping you guys are doing okay, and hoping you guys are following, the guidelines and staying safe. Before we know it, we'll be done with this, and then we'll be back to our normal routine. Um, so within that context, here's a few things that we can do at least so that we, keep the learning going. I know I've given you guys some time to catch up with some work. I'm hoping some of you again make the choice of continue working on submitting any work you haven't completed, anything that was due before that last Friday we met. And these videos right here, anything that I post up is just gonna be based on stuff we should be learning in class if we're in class right now. And again, to help you continue learning what you should be learning based on the Algebra 1 curriculum. So we're gonna start where we left off, which was the basics of exponential properties. So if you remember, and again, we started with activity 19. We talked about exponential expressions, what's a base, what's a powered exponent. So again, go back to your notes and review them. Also, I put a video on Khan Academy just to kind of give you a heads up of what to expect, so that it gives you some background again, uh, information of what we're going to be doing next in this video. Again, all this stuff should be reviewed. So based on the patterns that we saw, we identify some properties: the product of power property, the quotient of power property. So again, look at your notes. Also, um, the zero power property. Remember, anything to zero power is always 1, and we use expansion to show that. Then we talked about where's the next one? The negative exponent. Again, guys, we're gonna come back to this. So again, we saw the negative exponent, what it means. So again, notice that we're gonna come back to something like this. When you have a negative exponent, how do you write this? In our conclusions. So please review your notes on that, because we're gonna need it for what we're gonna do next. The other property we talked about was a power to a power. Power to product property, and power to quotient property. So again, we're gonna look at these closely for what we're gonna do next. If you remember, in before we left off, we talked about after activity 19, which was all this stuff. We're gonna jump into activity 22, which was functions equations. So in Alex, I gave you practice on functions, exponential functions, and the video I put up on Schoology was also based on exponential functions. So the two targets for activity 22 is understand the definition of exponential function, then graph and analyze exponential growth functions. So again, before I start with that, let me give you guys some review of what you're going to need, so that when we start doing graphing exponential functions, you understand how we're getting the numbers based on the input. So if you remember, let me give you guys an example. So review example. Oops. Review examples. It was this. If you remember, when we had from the previous work we did last week, was if I have, for example, 4 to the negative second power, it was the same thing as 1 over 4 to the second power. And we emphasize this, that if I have the power and it's negative, and notice that if I write this as a fraction, it's in the numerator. So when we expanded this and we saw why we're getting the negative exponent, is the same thing as now writing it but now it's in the denominator. And when we bring it down to the denominator, the power is positive now. And this is the same thing as 1 over 16. Here's another example. So if I have 5 to the negative third power, if I write this as a fraction, it's over 1. So based again on the properties of exponents, so given that the exponent right now it's negative and it's in the numerator, then we have to bring it down and write the denominator. And again, when we bring it down, when we switch locations, then that power becomes positive. This is the same thing as, again, 1 over 5 to the third power is 5 times 5 times 5. 5 times 5 is 25. Times 5 is 125. And then we started getting a little bit more complicated examples. So it's, what happens if I have 3 to the negative 3 power over 7 to the negative 2 power. So again, one at a time. So notice that the 3 is to the negative third power. It's in the numerator, so that means that it has to come down to the denominator, and the power becomes positive now. And notice that 7 to negative second power, 7 to negative second power is in the denominator, so we have to turn it into a positive. So now it's going to come back to the numerator, and it becomes positive 2. So now it becomes 7 to the second power. And if I simplify this, this is just 7 squared, which is 7 times 7, which is 49, over 3 cubed. 3 times 3 is 9, times 3 is 27. Another example. Guys, I need you to understand this, so when we start doing exponential functions, we're going to be applying the same rules. So what happens if I have x to the negative 7 power over 2 to the 5th power times y to the negative 3rd power. So again, one at a time. So I'll start with the numerator. Notice that x has a negative power. So that means if it's a numerator, I have to bring it down to the denominator. Notice that, so this becomes x to the 7th power. So I'm going to analyze the next one, which is 2 to the 5th power. Notice that it's a positive power and it's in the denominator, so all I can do is simplify this. So 2 to the 5th power is 2 times 2 times 2 times 2 times 2, which is 32. And then the third one, y to the negative 3rd power. Notice that it's in the denominator, so I have to bring it up to the numerator. So this becomes y to the positive 3. So again, so what I want to emphasize, guys, is that power. So again, if it's a negative power and it's a numerator, you have to bring it down to the denominator. And if it's negative power and if it's a denominator, you have to bring it back up to the numerator. So you switch the locations. And again, this comes back to the negative powers that worked with it last week. So I'll do one more example, and then I'm going to bring tie this together with the exponential functions. So last example. What happens if we have something like this? 2 to the negative 2 power, x to the 10 power over 3 to the negative 3rd power, y to the negative 2nd power, and everything is to the to the 4th power. So again, going back to the properties we learned last week, guys. So this is the power to the quotient power property. So if you remember, we like to think of it as a kind of distributed property where you distribute the power to all of these. And again, look at your notes. So if I simplify this, it becomes 2 to the negative 2 times 4 times x to the 10th power times 4 over 3 to the negative 3 power times 4 and y to the negative 2 power times 4. And if we simplify this, this is 2 to the negative 8 times x to the 40 power over 3 to the negative 12 power times y to the negative 8. And again, because we have negative exponents, we have to rewrite this in positive exponents. So one at a time. So notice that negative 8 power, so it's in the numerator, now it has to come back to the denominator. So this becomes 2 to the positive 8. X to the 40 power is positive, so it stays in the numerator, stays up there, x to the 40 power. Next one to analyze is 3 to the negative 12 power. Notice it's in the denominator, so we have to bring it back up. So this is 3 to the positive 12 power. And then the last one with the power is that base y. It's negative 8, so we have to bring it, it's in the denominator, we're going to bring it back up. So this is y to the positive 8. So if we simplify this, so if we do 3 to the 12th power, so let me do it on the side because I'm not going to. 3 to the 12th power. Okay. I guess I can use decimals for this. Not that. I can use a calculator. Or you. Later. Well, so use test decimals for function calculation, scientific one. Start practice. So 3 to the power of 12. So what do we get? 531,441. 531,000. 441 x to the 40 y to the 8 over 2 to the 8 power 2 to the power of 8, which is 256. Okay, so then now again, this is just some review work. So now we're gonna use this to address the learning targets, which is 1, understand definition of an exponential function, and then graphing and analyzing the function. So before I do that, if you look, again, this is 22-1. Page number is starts at 325. Here's the definition of an exponential function. So we've done functions before. We mainly stuck to linear functions, y equals mx plus b. So notice it's a whole different kind of a function. You saw already that this is not linear. It grows really fast. So it looks more like a curve. If you had the chance to do the Alex work that I assigned last week, you should recognize the shape of the graph of an exponential function. And then we're going to address it today. So this is what it looks like. So again, this is nothing new, meaning that we've seen functions before in the form of y equals mx plus b. Now we're looking at this one, which is exponential function. And how does it look like? F of x is equal to a times b to the x power. So I guess I can continue that here. So similar to linear functions, and I put it right here, guys. I'm going to use the slope interest form. Y equals mx plus b. And exponential function looks like this. Using exponential notation, function notation, it looks like this. F of x is equal to some number a times b for base to the power of x. If you don't like function notation and you want to use two variable notation, you can write as y is equal to a times b to the x power. Same idea. So to be consistent with the book, I know there's again, like a story behind this. We can come back and look at this, or actually have a better real life scenario about this. So, but I do want to emphasize stuff that we did in class before. So I want to start with, I think it's example 18. Yeah, this one. Example 18. Copy and complete the table for the function g of x is equal to 3 times x, 3 to the power of x. So I'll continue here. So we're going to do that example together. So they're calling it g of x. So g of x is equal to 3 to the power of x. So if you remember when we're doing linear functions, and I would say, well, once you write the slope intercept form and I match the slopes and the y-intercept and use it to graph the equation. So we're going to do the same thing to show that this is the same thing as that these are equivalent. So if I match these, I can see the x with the x. Very clearly see that b is b right here. So then what is that number a that I don't see here? And again, this means multiplication. So a times b. So what is that number? And if you don't see a number, it's going to be a 1. So notice that it is g of x equals to 1 times 3 to the x power. Is in the same form as f of x is equal to a times b to the x power. It's in the same form. Or again, if you want to write it differently, you could write it as y is equal to 1 times 3 to the x power. And again, if you match, you can see which one is which. Show you the same colors. So now we're going to make a table and then we're going to sketch this graph. So if you make a table for this, so make a table of values. And again, this part should not be new if you did your Alex work and if you saw the video I posted yesterday. So if you haven't done that, then watch this first, I suppose, and then watch the video, see if it makes a stronger connection. X and y. So I'm going to choose a few values for x. -2, -1, 0, 1, 2. And remember, this part is not new. You've done this before, but with the linear x function. Okay, when you plug in for x, do the math and find the y. Same thing here. We're gonna plug in for x, and then we do the math, and then we'll plot the points. And if you did the work on Alex, some graphing exponential functions, every time you created a table, you had to choose. You were able to type in the coordinates on Alex, and it will sketch the graph for you. So again, if you haven't done it, practice it. We'll do from scratch here since we're doing it on on the iPad. So I don't have to write down the 1 anymore because again 1 times 3 uh, times 3 to the x power is just going to be, it doesn't have an effect on that, so that's why we don't see the invisible one. So I'm just going to leave it as g of x is equal to 3 to the x power. So if I do the math, so if I do g of -2, so again I'm going to plug in -2, -2, -2. Remember, this is the same thing as 1/3 squared. Actually, let me just let me just rewrite it. -2 something over 1. So again, same as we did previously, we saw that negative exponent in the numerator, so we have to bring it down to the denominator. So the same thing as 1/9. 1/9. G of -1 is equal to 3 to -1 power, again over 1. And if we simplify this, we have a -1 power in the numerator, so I have to bring it down to the denominator. So it's the same thing as 1/3 to the 1 power, but 3 to the 1 power is just 1/3. Next input is 0, so g of 0 is equal to 3 to the 0 power. And anything to 0 power, again, we talked about that, is always equal to 1. I forgot to put 1/3. 1. Next one is g of 1, which is 3 to the 1 power. And again, 3 to the 1 power is simply 3. And the next input, g of 2, is the same thing as 3 to the second power, which is just going to be 3 times 3, which is 9. So I have enough points. So now I'm going to plot my table. So again, Alex, you have practice of putting a table. Again, if you haven't done that, I hope you get to that soon. And I'm going to sketch it here. So let me make sure I do an accurate graph. So okay, so it's going to be a little bit crowded here. So here's my graph. And again, you should kind of visualize it in your head if you have been doing the practice. So here's my x-axis, y-axis, and label my points 1, 2, 0, -1, -2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'll stop there. So my first point is -2 comma 1/9. So if you do 1/9, it's a very small number. Just to be precise, again, we can use a calculator. 1 divided by 9 is about 10.1111. So I'm gonna have to approximate that. So again, putting my first point, -2 comma. So it'll be 1.11, so it'll be somewhere here. And as accurate as I can. So I'm done with that one. Next point is negative 1, 1.3. So 1.3 as a decimal is 0.333333. So it's about a third. So, oops. Say it's somewhere there again as accurate as I can. That's why I ask you guys to have a graphing paper. When x is 0, y is 1, which is right here. So that's nicely easy to plot. Done with that. When x is 1, y is 3. So again, I hope you can visualize it if you have practice in Alex. And then when x is 2, we got y to be 9, which is right here. So notice that it's not a line anymore. It's making a curve. So again, it should not be surprised. If you are surprised, that means you're not doing your work. So then again, as accurate as I can, I'm gonna sketch my graph. So there it is. So that's what the graph looks like. And again, it's not more lines, it's now it's exponential functions. Okay, so if you look in the book, you know, again, we'll do some real life applications. There's something happening in the world right now that it's applicable. So I'll do a video and I'll put it up in Schoology so that you can look at it. But notice that if you look at everything in activity 22, again, never mind the application part of it. I'll do a video on that later on. But what I do want you to start practicing, it's something we can do this one together if you want. But about decay and growth, I can bring that up. But again, doing problems like this, you'll be able to do on your own. But I'll do another practice, and then should we probably do some of these, and then again we'll look at some real life applications of this. And again, it's a video so you can go back and watch anything that you missed. So let me practice this one. So we're gonna do now. This is moving to 22-2. Again, the idea is the same. We'll talk about growth and decay in another video. But at least I want you to do that. If you have an exponential function, make yourself a table and be able to sketch that graph. Okay. So we're gonna do this one now. G of x is equal to 1 over 4 to the x power. So I'll just write it here. I'll call it just f of x. Okay. 1 to the 4 to the x power. And actually, I'll just kind of call it g of x. It's fine. Notice that if I compare this to a times b to the x power, notice that it follows the exponential format. So notice that x and x are the powers, b and b, which is the base, and then there's that a that you don't see here, but there's an a. Remember, if you don't see it, there's a invisible 1. So again, when there's that, it's an invisible 1, you don't need it. But you see in other problems that you have to keep that in consideration. But because it's a 1, it doesn't make any changes on your product. So if you were to sketch this graph, x and y, and I'm gonna keep the same numbers as the previous one: -2, -1, 0, 1, and 2. So, and now again, I don't need that 1, so I'm just gonna keep it as g of x is equal to 1 over 4 to the x power. So I'm gonna start with plugging in g of -2, and again, because I'm not going to skip any steps, but remember -2, so I was going to plan for x, which is -2, and that's when in the beginning of the video, that's when I did that quotient property, remember? So whenever we have something like this, we want to distribute everything, this to the power here and to the power here. So what is the power of that 1 that we don't see? It's an invisible 1. What is the power to that 4 that we don't see? It's an invisible 1. So if I simplify this, again, go back to the beginning of the video. That's why I did this. That's why I did that specific example, so you don't need it here. This is the same thing as 1 to the power of 1 times -2 over 4 to the power of 1 times, let me just be a little more organized here. So this becomes 1 to the power of 1 times -2, and I put the -2 in parentheses because it's a -2 over 4 to the power of 1 times -2. And if you simplify this, this is 1 to the -2 over 4 to the -2. But then again, notice that we have the negative powers in the numerator and denominator, so we need to turn this power positive. So that means that this is going to be equal to 1 to the positive second power. I need to turn this power right here positive, so that means it's the same thing as, because it's in the denominator, now it's going to go to the numerator, so 2 to the second power. And now simplify this. 4 to the second power is simply 16. 1 to the second power is 1, which is just 16. So when x equals 2, y is going to be positive 16. So next input, when x equals -1. So again, if I do that, this becomes 1 over 4 to -1 power. And again, if I do the same thing as I did in the previous one, this is the same thing as 1 to the -1 over 4 to the -1. And because they have negative exponents, I have to switch the location. So this becomes 4 to the +1 over 1 to the +1. But 4 to the 1 power is just going to be 4. 1 to the 1 power is just 1. So this is equal to 4. Next one is when x equals 0. So this is equals to 1 over 4 to the power of 0. And again, anything to the power of 0, we talked about this, is equal to 1. Next one is g of 1. So the same thing as 1 to the 4 power to the power of 1. And again, if you do the distributive property that we talked about last week, distribute the power here and to that one. Remember that power we don't see is an invisible 1. So this is simply 1 to the +1 power over 4 to the +1 power, because the powers are positive. Nothing changes, so this is 1 over 4. If you want to see the decimal, it'll be 0.25. So 1 over 4, or again, if you write the decimal, it's okay, 0.25. You make that choice. And the last one, g of 2 is the same thing as 1 over 4 to the second power. You can expand this, or if you can apply the property, so the same thing as 1 squared over 4 squared, but 1 squared is just 1, 4 squared is 16, and as a decimal, 1 over 16. Let me use decimals for that. There it is. It's 1.0625. So, sorry, not 1.0. 625. Sorry about that. So again, you can write it as a fraction, or if you write it as a decimal, 0.0625. So now we can sketch this graph. Again, if you did this in Alex, then this is not difficult. And if you haven't practiced this, then practice it in Alex, because Alex gives you very good practice on how to input the graph. So notice that numbers are kind of big, so I have to be strategic about this. So I'm gonna probably, my graph is gonna look something like this. Let me see. 1, 2, 3. Probably though, well, I'm just gonna use the whole. It's okay. X and Y. X goes to 1. I'm gonna skip every other one, so it's gonna be 1, 2. Actually, it's okay. 1, 2, 0, -1, -2. I'm gonna label every fifth one. 5, 10, 15, and so on. So first point is -2, 16. So plot that point. -2, 16 would be right here. Next, so I'm done with that. Next one is -1, 4. So -1, 4 is right here. So notice again what the graph is looking like. So I'm done with that one. When x is 0, y is 1, which is right here. So I'm done with that. When x is 1, I got 0.25. So right here, approximately, again, I'm as accurate as I can. And then when x equals 2, I get 1/16, which is 0.0. So it's very, very small number. So I'm going to say that it's somewhere here. So again, notice the shape of this graph. Yes, this color. So notice that. So you can visualize that curve. And the big jump. So that's what the graph looks like. So again, in the next video, guys, I'll talk about decay and growth. But what I for sure hope that you can do is that if you have a function, exponential function, you should be able to make a table, complete the table, and sketch the graph. So here's one example. Oops. And here's another example. Where are you? Where'd you go? Right here. Again, you can rewind the video, see what you can do with the video to go back and look at anything I've said that you missed, and I'll put some problems up in Schoology to tell you what you should be able to complete for sure. You should be able to do these 4 problems, make a table, and then if you want to use the same values that I used, -2, -1, 0, 1, and 2, that's fine. Notice that I use a calculator for this. It's okay if you want to use a calculator. And then we'll talk about something a little bit more complicated. Okay. Then we can do a real life application. Like I said, there's something happening right now that that applies to exponential functions. So I'm gonna stop here. Again, if you had a chance to watch this, so that makes me really happy. And then again, if you have any questions or anything, uh, email me. Keep sending me those matches on Schoology. Let me know how you're doing. Again, anything that I have as that I did assign before the 13th, make sure you do complete. Because we will be submitting grades, and I'll put this up in writing. I know they extended our deadlines. I think it's going to be April 1st. So whatever I see, that's what I'm going to input in the gradebook. So